So this is the presentation for the Frankenserver group for CSE 145/237 of the spring quarter of 2023. You see for our team member slide from left to right, it's composed of the following people: Alexander Yang, Gavin Yuan, and Alexander Redding. Both Alexander Yang and Gavin Yuan are undergrads at UCSD, while Alexander Yang is a fourth-year ECE student and Gavin is a third-year CSE student. Alexander Redding, who is the team leader, is currently a PhD student also at UCSD. So it's been shown that both the cost of manufacturing and the use of technology and power consumption both contribute to carbon emissions, which negatively impact our planet. A research group has shown that by reusing smartphones, which usually get decommissioned after merely 2 years of their service, can be repurposed for use in computing power for cloud servers, and etc. As such, we aim to accomplish the same thing by using SD-RAM instead of smartphones. As you can see by this historical breakdown of DDR generations chart, we can see that by now present time, DDR3 production would become almost obsolete. As such, leaving good DDR3 behind as companies manufacture DDR4 and 5. And for our goals, we reach to answer the overarching question, can and should we reuse old RAM? As such, one avenue to answering this question is to see whether it's possible to interchange new RAM with older RAM. And our second goal is to see whether or not DDR3 in particular, in reusing it, is it as sustainable or more sustainable than using new DDR4. As for our first avenue / goal, we have written a translator parallel code that helps translate between the DDR3 memory to the DDR4 interface by communicating between the DDR4 and DDR3 files. And you see, by using both Gen 5, which is a system-level architectural simulator, and using our translator from the previous slide, we're able to compute the CCI, or computational carbon index, of both the DDR3 and DDR4 measured over its lifetime of use. As we can see here by the graph, eventually over time, both DDR3 and DDR4 will have similar CCI numbers. As such, we reach to our conclusion whether or not it is worth reusing old DDR3 in place of new DDR4. The answer? Maybe, because as we've seen by the previous graph, while at the start, the DDR4 CCI numbers are much higher than the DDR3's numbers because of the embodied carbon emissions from manufacturing. After well into both of their lifetimes of use, both DDR3 and DDR4 CCI numbers become so similar that it's hard to distinguish between them. As such, future work must be conducted in order to determine whether or not using DDR3 is actually more sustainable than using DDR4. We plan to do this by conducting more tests at a larger scale for both DDR3 and DDR4, in particular upscaling both DDR3 and DDR4 sizes to roughly 256 gigabytes. And this concludes our video presentation for the Frankenserver project works.